Hello, dear students. Good morning. Today we discussed about what is DC series circuit and what is parallel circuit. So, as you see in the figure, this is our DC series circuit and this is our DC parallel circuit. Okay. So, how we discussed in this lecture. So, we discussed about what is DC series circuit, what is parallel circuit, what is the current division in parallel circuit, and what is the application of series circuit and parallel circuit. So during this lecture, student able to understand what is series circuit, what is parallel circuit, and what is the application of series circuit and parallel circuit, and how the value of current is calculated when resistance is connected in parallel, and how to calculate the value of equivalent resistance of the circuit. So we start our topic, what is DC series circuit. As you see in the diagram, we have a series circuit like this. Okay, we have suppose if we want to connect circuit components, we say resistances is connected in series. Okay, so how we connect these resistances in series? So the methodology is, if we connect any terminal of one resistor connected to the starting end of another resistor, and similarly, negative terminal of one resistor connected to the positive end of another resistor, okay, and the remaining terminal connected to the DC supply. So the circuit is said to be connected in series. Okay, in series connection, current is always remains same, but voltage is different. Okay, so if we want to define series circuit, a circuit is said to be connected in series when one end of resistor is connected to the another end of second resistor, is named as series circuit. Means अगर एक end, suppose this is the uh, and terminal of one resistor, and this and terminal of one resistor is connected to the starting end of another resistor, say resistance R2. So this is named as series circuit. Okay, so mathematically, as we know, the voltage across resistance R1, R2 and R3, the algebraic sum of these three voltages is equal to the applied voltage V. So we may write V is equal to V1 plus V2 plus V3. Okay. So by Ohm's law, as we know that voltage V is equal to IR. Here IR is the drop. Okay, so V is equal to IR, as V1 is the voltage drop across resistance R1. So by Ohm's law, it is IR1. IR1 is the voltage drop across resistance R1. V2 is equal to IR2. So IR2 is the voltage drop across resistance R2, and similarly V3. V3 is equal to I into R3. I into R3 is the voltage drop across resistance R3. Here I1 R1, I2 R2 and I3 R3 represents indicates current is remains same, because in series connection current is same, so that's why we write IR1, IR2 and IR3. Okay, So taking common current I in both the sides, so we get resistance R is equal to R1 plus R2 plus R3. So R represents the equivalent resistance of the series circuit. When resistance is connected in series, so the equivalent resistance is R is equal to R1 plus R2 plus R3. So this is our series connection. Okay. So what is the application of series circuit? The series circuit is used for decoration purpose. Okay, so decoration purpose maybe in weddings or in Christmas light or Diwali decoration. Okay, so series circuit may be used. In series circuit, various light lamps are connected by a, also are controlled by a single switch. Okay, so this is our application of series circuit. Now our second topic is what is parallel circuit. Okay, as you see in the diagram, we have three resistances. Okay, if we want to connect these three resistances in parallel, okay, so how we connect these three resistances in parallel? What is the methodology for this? If we want to connect these three resistances in parallel, okay, we connect same terminal of all the three resistances connected to a common point. It is starting terminals and terminal of all the resistances connected together. Okay, it is starting terminal and terminals. So the resistances connected in parallel, named as. In parallel connection, voltage is always remains same, but current is different. Okay, but always one thing keep in your mind: in parallel circuit, voltage is always remains same, but in series connection, current is always remains same. Okay, so this is our parallel circuit and series circuit about. So if we want to define what is parallel circuit, a circuit is said to be connected in parallel when similar end, similar end means it is starting end and terminals, as you see in the diagram. When starting end and terminals are connected together, this is named as parallel circuit. Okay, as I1, I1, I2, I3, these are the currents across resistance R1, R2 and R3. Okay, so the algebraic sum of these three current is equal to I3. As you see, current I is equal to I1 plus I2 plus I3. Okay, by Ohm's law, current I is equal to V upon R. Here, current I is the total current of the circuit. It is a total current that is flowing across whole circuit. Okay, so I is equal to V upon R. Similarly, the current I1 is equal to V upon R1, as V is the voltage across resistance R1. Okay, similarly, current I2 is equal to V upon R2. Similarly, V is the voltage across resistance R2, and similarly current I3 is equal to V upon R3. We write V upon R1, V upon R2 and V upon R3 because in parallel connection voltage always remains same, whether it is R1, whether it is across R2, R3. Okay, so taking common V across both the sides. Okay, so we may write 1 upon R is equal to 1 upon R1, 1 upon R2, 1 upon R3. Okay, or we may write this equation is R is equal to R1, R2, R3 divided by R1, R2, R2, R3 and R3, R1. By mathematically we solve and we obtain this type of equation. So in parallel circuit, if we have more than one resistances or three resistances in the circuit, the formula for calculating the equivalent resistance is R is equal to R1, R2, R3 divided by R1, R2 plus R2, R3 plus R3, R1. So this is our parallel circuit, right? So what is the application of parallel circuit? uh, Application of parallel circuit, all home appliances is operated at same voltage at each application is controlled by individual switch. Means the application of parallel circuit is in our home appliances. Our home appliances, whether it is bulb, fan, tube light. Okay, these home appliances are always connected in parallel, where each appliances is controlled by a individual switch. If we want to on one fan, we have one particular button to start that fan. Okay, if we want to on the bulb, okay, we have particular switch to on the bulb. Okay, so this is the application of parallel circuit. Our home bulbs are always connected in parallel. So this is the application of say parallel circuit. Okay. If we want to calculate the current in parallel circuit, okay, as you know, in parallel circuit current is always different. Okay. Now if we want to calculate current across resistance R1, across resistance R2 individually. So in this topic, we learn how to calculate current across resistance R1, across resistance R2. Okay. Suppose when we have two resistances connected in parallel, so how we calculate the current across each resistor. So let's start. As we know that by Ohm's law, I1 R1 is equal to I2 R2. Okay, I1 R1 is equal to I2 R2, and which is equal to IR. Okay, and which is equal to V. That means the here I1 R1 is the voltage drop across resistance R1. I2 R2 is the voltage drop across resistance R2. Okay, and IR is the total drop across the resistance, across the circuit. Okay, and which is equal to V. V is the applied voltage. Okay, similarly, I1 R1 is the voltage drop across resistance R1. It is the drop across resistance R2, and I is the total current of the circuit, and R is the total or equivalent resistance of the circuit. Okay. Now, if we want to calculate current across resistance R1, okay, so how we calculate? As we equate current I1 R1 is equal to IR. Okay, so I1 R1 is equal to IR. So R is the total or equivalent resistance of the circuit. Okay, so current I1 is equal to IR divided by R1. Okay, so the how we calculate the equivalent resistance when we when two resistances are connected in parallel. Okay, so the formula is R1 R2 divided by R1 plus R2. This is the formula for equivalent resistance. Okay, so we put over here I into my R1 R2 divided by R1 plus R2. This is the equivalent resistance of the circuit. Equivalent resistance of the circuit. Okay, so I1 is equal to I into R1 R2 divided by R1 plus R2. Okay, and this R1 we place over here. Okay, so cancel R1 to R1, we get I1 is equal to I into R2 divided by R1 plus R2. So this is the formula for calculating the current I1 across resistance R1. Okay, in the same procedure, we calculate current I2 across resistance R2. Okay, by equating I2 R2 is equal to IR, and we get I2 is equal to I into R1 divided by R1 plus R2. So this is the formula for calculating current across resistance R2. So this is the method how to calculate current I1 I2 if two resistances connected in parallel. Now our second topic is how to calculate the current if we have more than two resistances connected in parallel. Okay, in this topic we have two resistances and two current. Okay, in this article we have more than two resistances connected in parallel. So how to calculate the current across each resistances? Okay, so the procedure is same, but the formula for equivalent resistance is different. Okay, if we have more than two resistances connected in parallel. Okay, so the formula for equivalent resistance is like this: R1 R2 R3 divided by R1 R2 R2 R3 and R3 R1. So this is the formula for equivalent resistances. Equivalent resistance when two resistances connected in more than two resistances connected in parallel. Okay, so by Ohm's law, we equate I1 R1, I2 R2, I3 R3 is equal to IR. So this is the total drop is equal to the drop across resistance R1, resistance R2, resistance R3 is equal to the total drop of the circuit, and the total drop of the circuit is IR. Okay, and which is equal to V. So now we equate one by one. Suppose I1 R1, it is the drop across resistance R1 which is equal to IR. Okay, so when we equate this I1 R1 is equal to IR, we get the value of current I1. Similarly, drop across I2 R2 is equal to IR. By equating these two, we get the value of current I2, and similarly when we equate I3 R3 is equal to IR, we get the value of current I3. Okay, so when we equate these three equations, then we get current I1 is equal to I into R1 R2 R3 divided by R1 R2 R2 R3 R3 R1. Okay, into में 1 upon R1. 1 upon R1 is from this side, from this to this side. Okay, so when we cancel R1 to R1, we get I1 is equal to I into R2 R3 divided by R1 R2 R2 R3 R3 R1. Likewise, we get in the same procedure, we get I2 is equal to I into R1 R2 divided by R1 R2 plus R2 R3 R3 R1. Okay, and in the similar way we get I3 is equal to I into R1 R2 divided by R1 R2 plus R2 R3 plus R3 R1. Okay, so these are the methods how to calculate current across resistance R1, across resistance R2, across resistance R3. Okay, so this is the methods. Thank you very much. If you like my channel, so please like, share, and subscribe my channel. Thank you very much for watching my lecture.